So VGG16. So VGG16 is a convolutional neural network. It was proposed by a research group called as Visual Geometry Group at Oxford University. So this VGG16 was submitted to a challenge called as ILSVRC challenge. This ILSVRC is a challenge, ImageNet large scale visual recognition challenge. So this challenge is conducted by ImageNet dataset. So this ImageNet dataset is a dataset where there are 15 more or 15 million images which are belonging to 22,000 categories, right? So this VGG16 was trained on ImageNet dataset. So it was out of these 15 million images, it was trained on roughly 1.2 million images which were belonging to 1,000 classes. So this VGG16 was trained on for weeks on the NVIDIA Titan Black GPU. Right? So this is one of the simplest model and with high accuracy on this ImageNet dataset. So this 16 stands for there are 16 layers in this VGG model. So this is the architecture. If you see, this is the simplified architecture of this VGG16. So this is layer number one, convolution layer number one. So this is layer two. Convolution and pooling is combined in a single layer. So this is layer three. This is layer four. This is layer 5, 6, 7. This is 7. This is layer 8, 9, and this is 10. This is 11, 12, and 13. This is 14, 15, and 16. So that's why there are 16 layers. That's why this is called as VGG16. Also, there is a version of VGG called as VGG19. So, but this is VGG16 where we have 16 layers. So if you look at the convolution layer, all the convolution layers have same size kernel and same stride and same padding. So the size of the kernel for this, or size of the kernel or filter in convolution layer is 3 by 3, 3 by 3. Right? Convolution kernel size is 3 by 3 throughout. The same size kernel, and the stride is one. Stride means by how much we can shift the kernel over the image. The stride is one everywhere, and the padding is same, means the input image will be produced of same size as output image after applying convolution. That is same padding. That means if you are giving input image of size, let's say 32 by 32, after doing convolution you will get the output of size 32 by 32. That is padding, same padding, right? So and pooling kernel is of size, pooling kernel is also of size same, 2 by 2, and stride of 2. So this is the configuration of this convolution kernel or convolution layer, and this is the pooling layer. So this is same throughout. There is no change in any layer of convolution or pooling. So for example, here if you if you see here, so this is the input image we are giving, right? Now the size of the input image is 224 by 224 by 3. 3 means it's a colored image, RGB, 3 for RGB. So now on this you are applying the convolutional kernel of size 3 by 3 with padding, with same padding. That means if you are giving input image of size 224 by 224, you will get the output image of size 224 by 224. That is the meaning of same padding, right? And stride 1, that means if you place the kernel over here, after applying stride, you will shift it by only on one location horizontally and one location vertically, right? So that is stride. So now after applying convolution operation here, there are 64, you will get this output. So there are 64 convolutional kernels. We are having 64 kernels of size 3 by 3, 64 filters of size 3 by 3. So the output of this applying convolution layer is 224 by 224 by 64. There are 64 kernels here, right? So now on this is the output of the convolution layer. So there are two convolution layers. layer 1 and layer 2, right? On this we are applying this pooling, right? So as the pooling size is 2 by 2 and stride is 2, so this pooling layer will reduce the size of this image by half. So that means it will become half. This image size will become half. So 112 by 112. So the image size is becoming half here in this layer. The image size is becoming half. So you see the size of the image is 112 by 112. Now in this here we are applying again pooling operation here. This is again a pooling layer. This is again a pooling layer. You see, it's a pooling. Sorry, this is a convolution layer. Again, this is a convolution layer. This was a pooling layer which reduced the size of the image to half. Now again on that image which is pooled image, we are applying convolution operation. You see, this is the convolution operation. This black lines. The pooling operation is red lines. So after applying convolution here, for applying convolution operation here, we have 128 filters now. 128 filters. So after applying convolution here, we get the output as 112 by 112 by 128. This is convolution layer here. And on this convolution layer, again, we are applying the pooling layer, this pooling, right? So this pooling again reduces the size by half. So this is pooling, right? So 112 by 2 is 56. So we get a output. So this is nothing but this layer here. This is this layer, right? And again, by applying pooling here, the size is reduced to half. This one, this is a pooling layer, right? And the number of filters here were 256. Convolution filters were 256. Here the number of, now we are here in this layer here. This is this layer here. So the number of filters here are 512. 512, there are 512 filters here. Then again we are applying pooling here. This pooling will reduce this size to half, right? So again we have 14 by 14 here, size of the image is 14 by 14, and now for convolution we are applying 512 filters here, 512 filters here, right? And then again that this is this layer here. Then we are applying pooling layer on this, right? After applying pooling layer, the size size of the image gets further reduced, and after that we are so size of the image here will be 7 by 512, 7 by 7 by 512. This is the size of the final size of the image after applying this pooling layer. Now on this we are doing flattening operation. Flattening operation means this 7 by 7 by 512. If we multiply this, whatever number we get, it is 4096. So we are making a one-dimensional vector here like this, 1D vector, 1D array. This is a 3D array. We are unpacking this array and making a one-dimensional array. And now this one-dimensional array is given as input to this dense layer where we have fully connected neural network. So this is a dense layer, fully connected neural network. And so this is fully connected layer 1, fully connected layer 2. This is fully connected layer 2. And this is finally output layer where we have 1000 units, right? And that's where we are getting the classification output. So this is the VGG16 convolutional neural network, which is a benchmark sort of thing. It is being used by many people across the world for something called as transfer learning, where people are using this pre-trained VGG16 model and solving their own problems. So this VGG16 had 16 layers. Just to summarize, VGG16 had 16 layers. 16, it's a CNN which is trained on the ImageNet data set, which is 1000. This CNN is 1000 class classifier, and it has 16 layers of convolutions and pooling. So the size of the convolutional kernel is 3 by 3 for every convolutional kernel, and the stride is always 1, and the padding is same. That is a convolution. And for pooling, the size of the pooling kernel is 2 by 2, and the stride is 2, right? So this is the simplified architecture of the VGG network.